Hey everyone, I'm Dr. Burns. I just wanted to welcome you to ME14 Mechanics of Solids for the spring 2021 semester. Just want to go through the agenda of what we're going to talk about in this first lecture for class 1 today. I'm going to take you guys through the syllabus for this course, go over what we have planned for our rough schedule for the entire semester, talk a little bit about the homework format and grading, my policies, the rubric I use, and how I do the grading, how many homework assignments we're going to have. Um, Discuss Blackboard. I'm going to be using Blackboard as a primary source of communication throughout the semester to present the lectures, homework, exams, and any materials. I'm going to talk to you about the quizzes. Plan on having weekly quizzes this semester to help keep you guys up to date with your reading and material. As far as the homework goes, one of the biggest things that I'm going to be focusing on is the format. So I have an expected format, some templates, examples, and I'll go through that a little bit later in the lecture. There's going to be 5 sets of problems that I'm going to be citing throughout the semester. There'll also be 2 exams. There's going to be midterm exams. There's not going to be a final. For the exams, you're going to be anywhere from 2 to 4 problems using the same standard format that we see in the homework problems. And the last thing we're going to talk about is the group project. A portion of your grade this semester is going to be dedicated to a group project that you guys are going to put together. They'll be due at the end of the semester. So a little bit on course information here for this ME14 class. So again, our class website is primarily going to be taught right through Blackboard. I will be doing some stuff with Teams as well, such as office hours and things like that, but majority of everything is going to be done right through Blackboard. Class times, this is an online asynchronous class, so there is no class times. There will be 15 weekly modules, and then within those modules, I'll have things broken down into individual lectures, materials, example problems, and things of that nature. The course is going to run from February 1st to May 11th, and the prerequisite for this course is ME 143. If any of you haven't taken this yet, please contact me so we can work out the details. My office hours are tentatively planned from 9:30 a.m. till 10:30 a.m. on Tuesdays. This will be remote through Teams. This is just tentative now. I want to see how this works with everyone's schedule within this class. We may be subject to change as I hear back from you guys if this time slot does not work. But the other thing I want to note is if you need extra help, please feel free to contact me in the chat on Teams or through email. I am on Teams pretty much 24 hours a day, so I try to make myself as available as possible I can for all of you. So if you have any questions related to course material, homework problems, example problems you're working through in the book, please feel free to reach out. And also, if you have any questions as far as the layout of the course, navigating through Blackboard, how things relate to other courses in the future, please feel free to reach out to me. I know it's a little bit different now with these online classes. You can't just raise your hand and ask a question right away, but please utilize the chat in Teams or email to do the same thing if you have any questions at all related to this course. So this is the textbook that I'm going to be using throughout the semester. So this is Mechanics of Materials. I'm using the 8th edition here, which is a new release from McGraw-Hill. I have your ISBN here. There's an e-text version and a print version, whatever works best for you. I know the other section of this course is going to be using the 7th edition, and that's fine as well. If you have an older copy that's a little bit cheaper, saves you some money, you're sharing a book with one of your classmates, that's all completely fine. I will be posting the full homework assignments, so you won't need the textbook for that. Just note if I reference equation numbers and things like that in my lectures and you're using an older version or older edition, it might not quite line up exactly. But other than that, if you have an older edition or sharing a textbook, that's completely fine. So a brief overview of this course and the topics that we'll be covering throughout the semester. We're taking a look at this first module here, just a basic introduction to mechanics and the course itself. And then we're going to start talking about the concept of stress, leading into stress and strain, talking about axial loading. Then we'll get into some torsion problems, talk about some pure bending, look at the analysis and design for beams for bending, a couple different types of beams that we're going to analyze there. Then we'll talk about some shear stresses in beams and in thin-walled members. Moving on, we're going to go into some transformations of stress and strain, then take a look at the principle of stress under a given load, talk about beam deflection, some different column stuff, and then we're going to end the semester discussing some energy methods. So as far as our course goals for this semester for ME14, Once you finish this course, I expect you'll have the ability to analyze a given problem in a simple and logical manner in order to apply its solution on a few fundamental, well-understood principles. So a lot of what I'm going to be focusing on throughout the semester is really grilling the importance of how to set up a problem, how to solve any of these engineering type of problems. What is the given information from the problem statement initial diagrams? What are they asking me to solve for? What assumptions am I making? Picking out, hey, what are my key equations I'm going to use to solve this? What method am I going to use to solve this? And then from there, applying those methods to get your final answer. So a lot of this semester, I'm going to be focusing on that, and that's pretty much the criteria that I'm going to be expecting as far as your homeworks and exams as well. Other course goal is to be able to provide a future engineer with its means of analyzing and designing various machines. So for this course specifically, machine design, and this is going to lead into some future courses at UVM, specifically ME 171 and leading into ME 124, your lab course as well. Now, with this being an online asynchronous course, there is going to be some computer and software requirements that you guys will need in order to be successful with this class. So as far as computer usage goes, what we're using computers for are, one, for viewing the lectures via Blackboard, and two, for some data analysis and plotting. And I specifically like MATLAB myself, but Excel could be used as well if you're more comfortable with Python or anything like that, but anything that you can utilize for some data analysis and basic plotting. Other required platforms and software, so you're going to need Microsoft Teams, so you can view the for office hours, communication, things of that nature. Blackboard to view all the lectures and videos and content that I'll be posting. And then the last two things that you're going to need is a scanner and a PDF reader. And this is for your homework assignments and exams so that you can scan things in and upload them to Blackboard. Many students are using their phone as their scanners, and that seems to work just fine now. I would prefer if you have the option to convert to PDF. It makes it a little bit easier for us to grade and easier for you to view once we do grade them on Blackboard. And I do recommend a PDF reader, and if possible, if you have access to Adobe Acrobat, so you can do some editing of the PDFs as well, that may be helpful, but not necessary throughout the semester. The last piece of hardware that you're really going to need is a good webcam. This can be either one that's built into your laptop or that plugs in via USB. And this is pretty much just going to be for our office hours if you have any questions so we can communicate back and forth. As far as the class goes, it'll be pretty much one way for the asynchronous on Blackboard, so you won't need the webcam for that, but you will need it if you want to communicate back and forth on Teams. For the next part of this lecture, we're going to get into some of the university policies. And I know these may be a little bit dry, but I think it's important that you get this information readily available to you, and we discuss some of the new policies that are going to be applicable this semester. So the first thing we're going to talk about is attendance, and in particular, how attendance relates to the pandemic itself as far as illness, isolation, and quarantine. So with everything that's going on, there's a good chance that some of the students may need to isolate or quarantine during the semester. Now, if this is the case, I ask that you please make Student Health Services aware of this so they can communicate this information to the Dean's office. Now, I will be able to plan for some flexibility in instances where you need to quarantine or isolate. This being an online course, all the material will already be presented via Blackboard. So if you're just an asymptomatic case where you need to quarantine, it shouldn't change too much for you, and you'd still be expected to continue your work. Everything, again, will be posted right on Blackboard. All of your quizzes, all of your homework assignments, and everything you need is fully remote anyways. But if you are ill or there is some other reason with the isolation and quarantine that you're not able to complete the weekly quizzes, homework assignments, things of that nature, please feel free to reach out to me and let me know, and we can make accommodations for you. So now talking about quizzes that I briefly mentioned, we're going to have weekly quizzes throughout the semester, and my goal behind these weekly quizzes is to help keep you guys on track and up to date with all the reading assignments and lectures that will be posted asynchronously online. Because I noticed one of the biggest challenges with these asynchronous courses is keeping a timeline and staying on track and on top of all the material for the course. So with these weekly quizzes, they're going to be based upon the reading assignments, my lectures that I'll be presenting, and the material on Blackboard. So this will encourage you to go through all of that and stay on track with it in order to complete these quizzes. These are just going to be 2 or 3 questions at the most for most of the quizzes, and they're going to be covering just all the content that you're going to see within your text reading. So as long as you've done the readings, you've gone through the lectures, these shouldn't be too difficult for you to complete, and will again help you stay on track throughout the semester. Discussing homework now, there will be 5 homework assignments throughout the semester. All of these homework assignments will be based upon your readings, material, example problem we've gone over in class. This will typically be anywhere from 2 to 4 problems each of these. You'll have a week to complete these. I'll expect that you follow the homework format that I provide and discuss with you for each of these assignments. You'll scan in your hand solutions and upload them to Blackboard where they'll be graded. I will be releasing all of these and you'll be resubmitting them all through Blackboard with the release dates. Everything will be posted, reminders as well. The due dates will be posted very clearly. You can take a look at the schedule. There are already tentative dates already posted there, and the release dates will be through Blackboard as well. Please note, this is another thing to help keep you guys on track with the course, that homeworks need to be turned in on time, and there will be some points deducted if homeworks are late. And again, I'm going to go over what I expect for the homework format and my grading criteria in a couple of the slides in a minute here. There will also be 2 exams, 2 midterm exams throughout the semester. We'll not be giving a final exam. They'll just be the 2 midterm exams. Midterms are going to cover material that we've gone over in class up to the point of that each exam. These are designed to be the equivalent of an in-class exam. So I know everything's remote, it's going to be a little bit different, but what I plan to do is give you a 2-hour window to complete these. So there'll be a set release time and a set time that you'll need to submit your final answers. These are exams that are designed typically to be done in class in 60 to 90 minutes, so I am giving some extra time to allow for any issues you have with internet connection, physically scanning and uploading your answers at the end. So there is extra time allowed for that, but these are still going to be designed as a timed in-class exam equivalent. So these will be released at a set time on Blackboard. Plenty of announcements in advance of when this will happen, when it'll occur, and you'll have 2 hours to complete it, upload it, and submit it back through Blackboard. The format for these exams is going to be very similar to the format for your homework assignments. So everything that you've done is for your homework assignments will be the same there. Only difference is homework assignments, you have a week to complete, so I do expect a little bit more as far as organization content for that, but as far as the general format goes, it'll be the same expectation for your exams as well. Grading. So the grade breakdown for this class, 20% of your grade is going to come from your homework. 20% is going to come from each of the midterm exams, so these combined together will be 40% of your grade. The online weekly quizzes will be 20% of your grade, and last is your group project will count for 20% of the grade as well. And this is your grading schema here. If students had any questions for what your letter grade equivalent is for your percent grade in the class, this is a breakdown from F all the way up to an A+ right there. So now we're going to jump back into a couple more of the university policies. So the university does issue a statement on academic integrity, and I ask that you please go to this link here and read through this and follow the guidelines for academic integrity throughout the semester. And I think this becomes even more important as we switch to online courses here, where you have more access to materials while you're taking exams. There's no supervision while you're working on your homework. So please take a look at this policy here and make sure you abide by this throughout the semester. So another thing I want to do spend a little bit of time on, again, being that we're stuck in a pandemic right now, is the university's COVID-19 policy. They do have a general statement regarding potential changes through the semester here. So as things change, as our numbers go up, is it going to cause us to switch to different modalities of teaching, things of that nature? Please reference this website here for these potential changes to the semester. The overview of this is that the university reserves the right to make changes in this course offerings, mode of delivery and degree requirements, charges, regulations, procedures, finance, health, safety, so on and so forth throughout the semester based upon what may or may not be occurring within the pandemic. So please, again, reference back to this page here for the university's statement on these policies. The other thing that we ask the students to follow is this Golden Green Promise. So this clearly articulates the expectations that UVM has for students, faculty, and staff to remain compliant with all the COVID-19 recommendations from the federal CDC, state of Vermont, and the city of Burlington. So this code of student conduct outlines policies related to violations of the Golden Green Promise. Again, there's sanctions, violations, including fines, educational sanctions, parent notifications, probation, and suspension. So please go to this link here to take a look at this Golden Green Promise. So UVM has issued some updates for the spring 2021 semester for the Golden Green Promise. So just a couple things to highlight. The virus is highly contagious. It's possible to contract the virus even when individuals follow all the safety precautions recommended by the CDC, state, and the university. The university is following all guidelines issued by the CDC and other experts to reduce the spread of COVID-19. However, on and off campus activities carry risk of exposure to COVID-19 and other infections. As university citizens, it's important that we hold each other accountable for our actions. So this is just the update that UVM has issued for the COVID-19 Golden Green Promise. So here is the Golden Green Promise here. I'm not going to read through all this right here, but I will leave this for you, what's expected of you, what you're promising to do within this Golden Green Promise right here. So this is listed out, and again, this is listed on the website link that I gave you as well. So as things are updated, please reference back to that website link for any updates on this promise or any other COVID-19 policies. A couple other statements that UVM has as far as policies go is the alcohol and cannabis use. So the Division of Student Affairs has offered the following statement shown down below here for use of cannabis and alcohol on campus. So again, please read through all of this as well to understand the university's statement and policy on this. Next thing I do want to mention here is student learning accommodations. So we have here is the main thing. If you have any disabilities or accommodations that are necessary, please look at the contact information down below here. I've listed out the phone number, website, and email for Living and Learning Center for the contact for SAS. So if you have any accommodations that you need, please reach out to them. If you have any questions for me, please feel free to reach out with me. And if you need any accommodations, we'll make sure they happen within this course. The university also issues a statement on religious holidays. So you can see the statement down here below and a website link related to that for further details on the university statement on this policy. Another statement, if you are a student athlete, there are some policies that we have here, and we can see the link is down below here. And I ask if you are a student athlete and you're going to be missing some classes and need to make up assignments, please just let me know in advance and we can make those accommodations for you. So the next thing I want to discuss here is course evaluations. Now, I want to spend a little bit of time on this here, especially now that we're talking about some of these new online classes and especially these asynchronous ones. This is a brand new area for all of us. Both faculty and students, teaching and learning side of this is a whole new area for all of us. So one thing that I would highly encourage and ask of you is to have direct communication with me. If there's something you really like about this course, a method that I'm doing, video presentations, things of that nature, please let me know. And at the same time, if there's some constructive criticism, you'd like to see more video presentation of example problems and less lecture stuff, or vice versa. If you're having technological issues with your computer, logging into Blackboard, things are hard to follow and find. Anything like that, both constructive criticism and any positive feedback you have, just to let me know what you like about the course and what you'd like to see changed, I would highly encourage you to do that. The course evaluations are great, but the problem with course evaluations that we found in the past are twofold. The first being we don't do them until midway through the semester and the end of the semester, which doesn't give us time to make these changes for you guys. And the other thing that we've seen is many of the course evaluations are only the negative feedback of what students didn't like or their frustrations with online learning, and not any positive feedback about what they did like about the course, what we are doing in the right way. My main goal in teaching you guys is to present this material in an effective manner that you guys get everything that you need, even though this is an online asynchronous course. So if you have anything that you'd like to see tweaked, any feedback, positive or constructive criticism, please reach out to me directly. We can have a direct conversation. You say, hey, you know, I really like what you're doing with the online example problems. Could we go into a little bit more detail? Or, you know, I think more time would be better spent working through example problems and less time on lecture slides. So things like that, please reach out to me directly so we can make those changes right away. And also encourage you to talk with each other, go through Teams, chats. That's one of the main things that we're going to be missing this semester, is that in-person group conversations back and forth in real time. And we don't get that in an asynchronous course. But we do have the resource of Microsoft Teams and the chats and things like that. So I'd encourage you, even outside of office hours, to meet with other students in groups via Teams and have these conversations, work through problems together, discuss the course, things you'd like to see changed and modified, and let me know those as well. So that's a brief statement I wanted to put out there as far as these new asynchronous courses and feedback to me. So moving on to a couple more university policies here. Code of Student Conduct. So we can see we have a link here. Please reference this here. And we also have our rights disclosure listed in a summary right here. And please reference this link as well to go over that. So now what we're going to jump into is the course schedule. So I've broken this down. This is all available on Blackboard. I have an Excel format, a PDF format as well. So the way that this semester is going to work is I'm going to break this course down into 15 different modules. Each module related to a week within the semester. So I have listed out here for module 1, this is the start date, the end date, this is related to week 1 of the semester. Here's the topic that we're covering. So this is tentative, but I've gone through and this should stay fairly accurate throughout the semester. If all of a sudden we're going down and we say we get to week 6 and there's a lot of interest in questions and problem solving with pure bending, we can spend a little bit more time for that and maybe bump some things around. But for the most part, this will be the outline for your schedule for the semester, the topics we're going to cover, and the related dates to each of those topics. I've also broke this down into a little bit more detail for you guys for all the weeks and how it relates to what sections within your textbook. And you can also see on the right over here, okay, during Module 1, this will be your reading quiz 1 that's going to cover the content in this topic area for Module 1, your homework assignment, the assigned date, A here, the due date right there with D, all the way down. Your exams will be listed here as well. And I've done this first page right here. This first slide goes up to week 8. We'll move on to the next slide, where we start with week 9 through week 15, continuing on here with all the topics as related to your textbook there, your homework assignments, your reading quizzes. So this again is a way that I'm hoping to help keep this a little bit more organized. Even though we're asynchronous, you can always reference back here to your schedule. Okay, this is where I'm at in the semester. This is where we're going to go next. This is when my next homework assignment is due. This is when my next exam is. This is when my group presentations are. So as you're doing that, I'm hoping this will help you guys keep a good timeline throughout the semester and keep on track of all your assignments, all your readings, all your exams and everything throughout the semester. So going into a little bit more detail with the homework guidelines, as I mentioned earlier, there's going to be 5 different homework assignments throughout the semester. All these assignments are going to be released on Blackboard, and you'll need to scan and resubmit them through Blackboard as well. All the due dates are going to be posted on Blackboard, and I'll send announcements as well. And as you just saw, the due dates and assignment dates are also posted on the lecture slide. So I've tried my best to give you guys all the resources in multiple areas so that you can have them readily available for you. As far as the format for this goes, I'm going to break this down in some detail. I am going to stress that you really do have a good, organized and neat method for solving these problems and writing out your homework assignments and exams. I feel that this is very, very important for you as you're solving it to quickly reference back, oh, this was all my given information. This is what they were asking me to solve for. And also for the grader to be able to look at that and follow through your work as well. This is going to carry on as you start your career as well. One of your coworkers, your boss, looking through your work needs to be able to easily understand what your method was, what you were doing to solve this problem. So that's why I'm going to focus a lot of the energy this semester with the homeworks on the format that you're going to be presenting them in. So on the top, it's going to be important. What homework is it? What class is this? What was the due date? Your name? All that information. A lot of this was a little bit more crucial when you're handing in hard copies. Now that you're on Blackboard, I do see a lot of that information as you submit it, but still stay in this habit here of writing this out on each sheet of paper for your homeworks. One thing I do ask is to please use only one sheet as you're writing out your hand solutions for this. Back when you were handing in hard copies before the pandemic, there'd be a lot of bleed through, or you might not flip the paper over to see it. With now the new technology as you're scanning in, what I've noticed is if you write on both sides of the paper, you still get that digital bleed through, and sometimes the stuff in the back scans through the front side of the paper. So I do ask that you only write your solutions on the front side of the paper. Smart tablets, any of that thing you may be using to do it out by hand digitally, that's acceptable as well to upload. If you are doing a hard copy, then scanning it in, please scan it in as a PDF and then upload it through Blackboard. PDF seems to work the best. I know a lot of your phones can scan them in as TIFFs and JPEGs. If you can do the conversion to PDF, Blackboard seems to work better with PDFs rather than image files. Now we'll jump into part D here. One thing I do encourage you to do is to work together on these homework assignments. So as I mentioned briefly earlier, I know one of the biggest things we're really missing throughout the semester is that in-person communication, sitting down with a group of your fellow engineers and students to work through, brainstorm, come up with ideas as you're solving this. So even though this is an asynchronous remote class, I really do encourage you to take advantage of any type of situation where you can still do that safely. So the first one being getting together with a group on Teams, setting up a private meeting outside of office hours that you guys can brainstorm these problems and work together on them with other students in the class. If you are lucky to be quarantined or have a roommate who is an engineer as well, I would encourage you to work together with them if they are in your class. I know that's not always the case for everybody, but if that does, please take advantage of that. In any way that you can, work together, discuss these problems with each other, and work together. A lot of engineering is learned that way. You know, something you might be stuck on for hours and hours and hours. One of your teammates or other students in the class was like, oh, I did this. And just them mentioning something gets you moving forward quickly to the next part of the problem. You're not just stuck staring blankly alone at a portion of the problem. So please do take advantage and work together on the homework. That is something I would encourage you to do. With that being said, please, don't cheat, don't copy, don't just hand in somebody else's homework. And if there is some acknowledgement, if you met with me, the TA, other students, and they helped you out with something, please make a note of that in your assignments when you turn it in. Hey, I worked with Mary Jones. She mentioned I really needed to do this free body diagram, so we both worked together to come up with a SolidWorks drawing. So we're both using the same SolidWorks model for our free body diagram for problem number 2. That way, when the grader gets it and sees that everybody has the same exact CAD drawing for their free body diagram, that did they copy? Like, no, we all sat down and worked on this together. So some things like that, please make sure of that. So that's the rest of these right here kind of address that same type of situation. Basically just don't violate the academic integrity rules that we discussed earlier. And be clear if you did utilize some resources with your homeworks as well. This will be different for exams. Exams I do expect you to work through alone, but as far as your homeworks and your group project, please do take advantage of the opportunity to work together with other classmates and students. So continuing on with our homework policies here for our format here, make sure that you include your force moment diagrams, any types of coordinate systems that you'll be using and chosen throughout the problem, vector notation clear and correct. So whatever it is, please make sure you label things very clearly. Any units that you're using, it's very clear what you've done, what your governing equation is, what all the given information is in the problem statement, what they've asked you to solve for, everything clearly labeled, easy for someone to follow through your work and see what's going on and what you've chosen to do for your solution. So that brings us right into our grading policy. So what I'm planning to use for my grading policy for the homeworks and for the exams as well is a 10-point policy, where 8 of these points are really just how you set up the problem, and the last 2 are the actual getting the answer right. So if you take the time to set this problem up right, you can get a bulk of the points even if you get this final solution wrong. So the first 2 points are going to be for format. Is your name on it? Did you write out all the givens from your problem statement, initial diagram? Did you write out clearly what they've asked you to solve for in the problem? Have you have everything labeled? Is your coordinate system there? Do you have everything labeled correctly? So all that right there, setting up the problem just with that there is going to get you 2 points. The next 2 points is for neatness. How easy is it for someone else to follow through your work? So as the grader's reading through this is going to be up to the grader's discretion. How easy is it for them to follow through your work? Stuff all over the place in a jumble and it's hard to read your handwriting, or did you take the time to write it out neatly, type it out, whatever it may be, leave space in between with easy steps to follow, putting little notes on your thought process as you're going through your solution. So 2 points for how neat and easy it is to follow. The bulk of the points is the correct method. So this is going to relate to, did you use the correct approach? Did you choose the correct governing equation? Relating back to the textbook readings, lecture slides, things of that nature. What approach did you use? Is this the correct approach? Even if you plugged something in wrong during that approach, if you've chosen the correct solution method, the correct governing equation, you can still gain all 4 points there. Your last 2 points are the correct final answer. So this, only 2 out of the 10 points there. So if you did plug something in wrong, drop a negative, and it does bump your answer wrong, you're not going to lose a ton of points. You're just going to lose 20% there at the most. And if it's a carry through and we can see it's just a negative, you probably won't even lose the full 2 points on that there. So that's just a quick overview of what I expect for format on the homework and exam problems and how they will be graded. Again, these are all be submitted through Blackboard. There is a grading rubric there as well that the grader will be using following this scheme right here. So the last thing I want to mention here is the group project. So as you saw in the grades, 20% of your grade for this course is going to be a group project. Now this is something I want to mention now because I want you to start thinking about it from the beginning of the semester, start getting together with groups, and that's another thing here. The fact that we have a group project, I'm really hoping is encouraging you to interact with other students, even though this is an asynchronous course, get together and maybe even utilize some of these students you're working on the group project with to work together on the homework with as well. So for this group project, basically what this is I'm going to have you guys create your own problem. So you're going to pick a practical problem from anything we've worked on through the semester. And you can start taking a look at that now that I have that syllabus up there with a breakdown of everything they're going to be looking at throughout the semester and going over. You can start thinking about practical applications you'd like to do. Then what I'm going to have you do is actually create your own problem. So as a group, you're going to work together to create a problem. It's going to be something similar to what you've seen in the book, my lecture slides, some of the exams, but not an exact one. I don't want you to just go out there, Google search a problem from another textbook or a different edition, and then put your name on it. I want this to be something fun, something that relates to something you're interested in. Could be a work project, could be a project for another class, could be something just a project on your own at home, or something you've always been interested in. So an example of this here, I did this for my ME12 class years ago as well, and this was quite a few years ago. This is when Angry Birds first came out on phones. So a lot of the ME12 dynamics course had to do with projectile motion. So I had some students that came up with their own problem related to an Angry Birds problem. So they had, okay, if I pull this back here, it's going to be released at some set velocity and released at this angle. How far does it go? Or how long does it take to reach a target? Or what is the peak velocity? What is the peak height? Things like that. Based upon all the information, they created an Angry Birds problem. So that was something interesting that was not a direct copy from another textbook or a problem we've done in class, something they thought was interesting relating to something, an app on a phone. So that's just one example. With this course here, you may find something with energy that you want to do, or something within one of the other topics that relates to you, or something that you're interested in. But again, I just ask that you don't copy one. Enjoy this, take the time, and make up one with your group on your own. With that there, as you're creating the problem, I am going to ask that you come up with a diagram illustrating the problem. So as you'll see throughout the semester, we're going to do a couple different types of problems within the class. Some of them only have a word problem and don't have an initial given diagram, and those are usually the more difficult problems to solve, because from that wording, you need to then draw out a diagram, visualize this on your own. So one thing I would ask for your problems here is to do that within the problem that you create and come up with an illustrating diagram for it. It can be something simple, it could just be the object that you're working with, or the project or mechanism itself. It could be something even more intense than that, depending on what you'd like to come up with for your problem. Next, I'm going to have you write out the problem statement for this, tell what's going on in the problem. In this statement, it's going to provide all the necessary information that this other student's going to need to solve this problem. So once you've created this problem, the next step is to go through and solve it. And I know that these two steps are going to kind of be back and forth dependent upon each other. Just from doing this in the past, a lot of times you may think that you've given all the information you need to solve the problem in parts A and B here in this top section, but then when you go to solve it with your teammates here to create the solution for the problem, you may find out, well, I made the assumption that everybody was going to understand that there was no friction involved, but you didn't clearly state that in your problem statement. So as you're going through and you're looking through this, pay attention to those things and list out in your problem statement, please assume there is no friction. Whatever it may be, please assume that the pulleys have no mass. Things like that are going to be important for you to put into the problem statement here for other students to solve your problem. So as you're creating your solution, please clearly label everything that you're doing in each step along the way. Keep everything neat and organized. Show all the general equations and maybe even write where those are referenced to in the textbook. Explain your thought process. So write out a little note next to each one about how you're solving each step of the problem. Clearly define and label your chosen coordinate systems. Draw out your free body diagrams and use correct units. Now, the reason I'm asking for this much detail is twofold. Because in this project, you're going to be at the end of the semester presenting your solution. You're going to be creating a video like this as you're going through your solution, and this is going to be uploaded to Blackboard for all the other students in the class to see. The second reason I want you to do all this is the other part of this problem is that when you create your problem as a group, you're going to be distributing that to all the other groups, and you're going to be solving all the other groups' problems. So let's just say there's 6 total groups in the class here. You're going to be solving the 5 other groups' problems. You're going to turn it back into that group, and they're going to grade your solution to those problems and give it back to you. So having all of this done is going to make your life a little easier as you grade the other group's problems. And I think you're going to learn a lot within this process of creating and grading your own problem and doing your video presentation of it. So again, this project will be graded and count towards your group project section of your grade. So you're going to have 3 different parts essentially. You're going to have the problem you've created, your solution to that, and your video presentation at the end. And also the other part of this is going to be your solution to the other group's problems. So all of those are going to go together to count towards your percentage of 20% of the group project grade. So I posted the group due date on the syllabus here. If that changes, we'll update you throughout the semester. Things you need to do, your problem and solution will be handed in to me, and you'll be graded. You'll be grading the other group's solutions to your problem based upon that same 10-point grading criteria that I discussed. So we'll get into some more details of this, but I wanted to put this out there from the beginning of the semester so you guys can start thinking about your group projects, start forming teams, get together and brainstorming for this here. As we go through this, and again, this is the same grading criteria right there I have listed again below for how you're going to grade the other students' solutions to your problem.